call. Okay.
Mom said I'm from Istanbul. From my dad's side.
Okay. And yeah, I think I started recording now. So, and here's the outline. We're going to start with a little bit background about what version control is. So Git is one of the version control. And then we can explain a little bit about GitHub, which is a website, which is probably one of the most popular place people store their code using Git. And finally, we're going to talk about GitHub Pages, which is like an additional feature on GitHub, which allows you to host your website online and similar to have like your server and host your page. But GitHub Pages make it much easier to do. Okay, and first is what is version control? Maybe give me that. Ah, I couldn't see. So version control is a system that records changes to a file or set of files over time, so it can record. Yeah. So essentially, version control it saves different versions of the file you work on. And this does not have to be, say, a code file like a JavaScript or HTML file. Could be any files. Could be Microsoft Word. Could be, I don't know, a PDF. So you can save multiple versions as you work on it, and later on you can go back to any previous versions if you want. Okay, and so one example would be, say, you can use this to save your code files and HTML, CSS, JavaScript, or Java, or any other code files for that reason. Okay, and hey, let's go next one. Yeah, and as I mentioned, you can do any types of files on computer. You can do a Java file, Microsoft Word, a picture, or PDF, and these are all work. So there are a few different variations of version control. The first one is local version control. So, and many people's version control is just to make a copies of the files with a version number. And so, for example, you're working on a Word document, and then you say you save version 1, and later on made more changes. You make a copy and name it version 2, and go on and go on. Okay, and so this is maybe a slightly more advanced compared to just have multiple copies of the same file, one for each version. You might have kind of version database, which saves all the different versions of your file. So that's your final file, and version 1 and 2 are the two early versions of the file. Version 3 will be the latest one. Okay, and then it can potentially, and this is quite simple to do, but then you can see you can have potential and issues with that as well. And you might easily write to the wrong files because just you open the wrong version, or you make other changes or delete it accidentally because everything is done locally. And also, and this approach does not scale very well with large number of files. And say if your file is just one single Word document, that's okay, you can version it. But let's say you are writing your app, then you have multiple files, including say JavaScript, CSS, HTML files, and you might have picture files as well, maybe some external library files. And then if you manually keep tracking, like make different versions of all these files, and it becomes much more difficult to keep track of all these. That's what it means by it does not scale with large number of files. Okay, and another issue with, and what we saw previously, the local and version control is it does not support collaboration. And so you as a person would have all the different versions of the file on your computer, but other people in your team cannot access them. You have to either say send them by email or sharing them with some online file service, and then you have to keep it up to date and becomes a bit cumbersome. And so this is where the centralized version control system comes in. And so essentially you have a server which is not hosting on your computer, it's maybe somewhere online, and which keep a database of all the versions. And everyone on the team can access this central database. So, and then can get the latest version or any early versions from the central server. Okay. And so the examples of these systems including CVS or Subversion. And did anyone heard of these before? So this was quite popular, maybe say 5, 10 years ago. Can I see a show of hands with yes and no? And so if you have heard of either CVS or Subversion before, please raise your hand. Ah, okay. Yeah. Most people, okay. All of them not, yeah. Okay. So when you start your job, if you're lucky enough to find a developer job, maybe in some of the companies, they might still having the CVS and Subversion, but it's getting rare now. Most of the people will be already, or software developer company would move on to the Git by now. Okay, and then we have kind of another more advanced version of version control, which is called distributed version control system. And so Git is one of these. And you still have a server which maintains a database which has all the versions that everyone can access. So that is the same as here. You have this server which contains all the versions. But the only difference is now is, say, all the client, it will also have a copy of the version database. So if you look at previously, and each person only maintain one version you get from the version database, but you don't have a copy of the entire database. Where in this distributed control system, which Git is an example of, each person will maintain its own copy of the version database. And then so that means, and for example, if there's problem, some connection with internet connection to the server, or the server crashed, and the person can still work on his own because it has the copy of the entire database stored there. And then also, for example, if you lost the database on the server, you'll be able to restore that later just by using the local copies each person in the team have. Right? And so that's kind of the main advantages of the called the distributed version control system, which what Git is. Okay, and now we're gonna talk a little bit more about the specifics related to Git. Okay, and so in a Git system, so basically you install Git or run Git, and then it will track all the files that you want it to track, and it will say the files are in one of these stages of Git or states. So it's called modified, unstaged, and committed. So modified means you have made changes to the file. So basically, Git would automatically monitor all the files that you want it to keep track of. And then if some changes made to one file, it will detect that. And that file goes into the modified state. Okay, and then staged means you want Git to save the modification. So sometimes you make a change to a file, but you say, that's okay, I don't want to include that in my version database. That's completely fine. You have the full control. So you need to tell Git what are the changes you want it to save. and you do this by stage. So the staged file means the files that's being modified, and you told Git, say, I want to save these changes into my as a new version into my version database. And finally, the other state is called committed, and the committed is the state when the staged changes are actually saved. And so after you tell Git, say, these are the changes I want to save into my next version, and you do a commit, and then those changes are saved. And in the first instance, and it's usually only saved at your local database. So if we go back here, you can see each person have on their computer a copy of the entire database. When you commit some changes, that changes to your local database. So it doesn't exist in the server or other people's version database yet, but that's okay. That's the part we're going to cover later on. How do you send the changes to the server so other people can get the changes as well? But for now, I just need to say, once the changes are committed, that means the changes is saved. A new version is created, including those changes you selected to include there. Okay. Yeah. So this is then related to the three main sections about the Git. And this is something useful to know, but in actually when you're using the Git, you don't have to worry about this too much. And so the first thing is called working directory. And so that's essentially is what you are working on. So for example, usually this is a directory, contains all the files you want to Git to track. For example, this is a directory contains your HTML, JavaScript, CSS files, and maybe any other image files that you are currently working on. So that's your working directory. And then there's the staging area. Okay, and it's actually usually part inside the Git directory, and that's a hidden directory. You probably will not see it by default, but the staging area is where all the staged changes are. And so if you remember from the previous slides, we have these three stages, and once you make some change to the file, you can stage the file, or stage the changes, or stage these files, and these goes to the staging area. And finally, you have the actual Git repository. This is where actual changes are saved. So you're working on your file directory, and you choose to stage your changes. That goes to the staging area. And finally, you commit your changes. That means save the changes to a new version. And this is usually, again, in the Git directory. Okay. And I think that's all you need to know, really. So you have your working version, you stage your changes, and finally you save those changes. And quite similar to the three different states we had mentioned in the previous slides. Okay, yeah. So when you're using Git, and so these are the three steps. So you will modify the files in your working tree or working directory. And this is just the same as what you would do normally. So as you adding more code to your, say, HTML file, you are modifying your files. So this is you would do without Git anyway. So these two are different. Then you have to stage the changes that you want to commit. So first, you can select which file to include in the stage, and all the changes on those files will be included in the next commit. So once you do the stage and you do the actual commit, essentially saving the changes, which creates a new version in your version database, represents the latest states of your code. So it is possible that you make some changes but you didn't stage those changes, and then those will not be saved into a version database in the latest commit, and those changes will not be part of the version database. Okay, I think that's probably so mainly you just have to remember there are three things. You have the collection of the files you're working on. For any changes you want to save, you have to stage them first, and finally you commit them, which saves the changes into a new version. Yeah. So that guess that's all the background of the series I want to cover. Now we're gonna get on to the more practical part. And first, and to use this, you need to install Git. And to do that, first you can check if you have Git installed or not. And so, for example, on my computer, I can check whether I have Git installed or not by typing this command and in a command prompt on Windows or terminal on Windows on Mac OS. So this is what I'm going to do now. And if you see something like this, it shows a version of the Git. That means it's already installed. And because I am using a Mac, so it will see something similar to this. It says Apple Git, that's the version. And if you don't have this message, that means you didn't have the Git installed. And then in that case, you need to download it. So that's the URL. We'll go get you to the download page. So I'm going to just demonstrate on my computer first. And can you see the text okay in my terminal window, or is that too small? Can you please click a yes or no? Please click a yes if you can see it. And a cross if you can't, because that's still too small. Okay, most people can. I think there's a couple can't. I'll make it slightly bigger as well, just a bit bigger. Okay, so I'm gonna type in this command, git. So that's kind of, you call the git for everything. So that's one of the options, is to show version. And the only thing you have to remember is you need to use double dash or double hyphen. So you type in git version. Okay, and so you can see I got the message back. It says Git version 2.24.3. Okay, and that's the Apple version of Git. Obviously, that's already improved. That means I have Git installed on my computer. But if you don't, you need to go here to download your Git. Oh, I don't want. So this is what all the page look like. And then depends on your operating systems, you can choose Mac, Linux, or Windows. And here it's usually automatically detect which operating system you are using and providing you the option to install. And this will be fairly straightforward. You click, you download the file, and you double click, and it will run the installation process, and just as any other software. Okay. And if you have a computer, and I will encourage you to follow along and install it. And if you have any questions, and you can just put that in the chat. And so I have one question says, if you don't have the latest version, would that be a problem? And usually not. We're only using the fairly basic functions of the Git. And so I think so long as it's 2 point something should be fine. And if you have something like 1 point something, maybe a bit that's outdated, and you can always just install the latest version just to upgrade. Okay, and okay, and before you can actually use it the first time, so if you've never done that before, never have Git before, and the first time you install it, you need to do some configurations, set up the basic information so Git can know properly how to use your, how to, and use, it's mostly just information about you, who you are, your email address, etc., something like this. So you need to, the command that you will need to run is called git configure, and then it allows you to set up Git. And you only need to do this once when you first run. And say, for example, you already done this before, you use the Git, and you upgrade your Git to a later version, and these configurations, you don't have to do it again. All the information will be saved. It will be not lost during the upgrade. Okay. And also you can always change these settings by run the same command again. So you can, even you already set git configure before, but you're not happy with information, or for example, your email address changed, you want to use a different one, you can always use run just git configure again to show, to change those settings. Okay, again, we're going to try the first command, and which is git configure with the option says list. It will show all the existing settings. So this will be something that looks like on my computer. And if it's your first time, you're probably not going to see much. So let me switch to my terminal. Okay, so I just do the exact same thing. I say git configure and then list. Okay, and so this is something a bit different. So Git can save your username password, for example, to GitHub. So it says here it's using the the Mac OS X keychain to save the username and password. And this is the part you always need, the minimum information you need. So you need to set your name and email. So that's my name and my email. So if you don't have these listed yet, so what you need to do is actually to configure it. So you say git config -global user.name, and then this part will be your actual name you want people to see as part of Git. So then later on, any changes you made or any new versions you created will mark it's done by Joe Doe or whatever name you put here. And then similarly, you need to set up your email using similar config command, but followed by the actual email address. And so the way this works, you would type in, say, git and configure -global and user.name and followed by name. And in this case, I already have name here, which is my name. And then if I can change it. Now, if I do this again, it will change my global name. So I can just type in Kai. And then if I do git configure list again, and you can see now my username now changed to Kai. Yeah. And you can do this now. I want to just change that back. Now can I change back? And you can do the same for your email address. So you can say git configure global. So global just basically means these settings applies to all the GitHub repository. And then you say user.email and some other emails. I mean, in my case, I didn't want to change anything, so I'm not gonna actually run this command. But for you, if it's new and in the first time, there will not be any settings and for the username and user.email, and you just need to run these commands, say first set the name and the second time set the email. And if you run just git configure -- list or -- list, you would see at least some information like this. That means you are now okay to do, for example, and to do pull and push from GitHub. And without this, you will not be able to. Okay, and then we're gonna come to the next part, which is creating a Git repository. Uh, and so a repository, just a special term, usually just means a directory that you want Git to track. So you can put all the files you need in that directory and make that a repository. But it can be more than one file. So you could have lots of different subdirectories and different types of files in that as well. So there are two ways you can do, and you can potentially create a local repository first. That means you create your local database, Git database, and then push it to a remote server, something like a github.com, and then other people will be able to access it, or your local copy will be saved or be backed up in the remote server. So you will not lose any files, even you lose a computer, because that's now saved on a remote server. And today instead, we're gonna do a slightly different way, which I think is easier, especially when you first started. So what we're going to do is we're gonna create a repository on a remote server first. So this remote server is github.com. And then we'll copy, or in Git terms, it's called clone, it to your computer. Yeah, so gonna using this, use the server gonna use here is GitHub. And then, so this is also where you need to use to put the code for your coursework, actually all the coursework, starting from coursework 1. So before we go into actually showing you how to do this, and just maybe a few points about what GitHub is, and it is probably the largest online host or server for Git repositories. So currently it has more than 100 million Git repositories, and most of these are open source projects, or almost all the open source projects use it for hosting its code online. So so the open source software basically means you can get the source code, but you need to put the source code somewhere so other people can use it. So most open source projects will use GitHub to do that. But besides hosting the source code, you can also do issue tracking, code review, and the collaborations on GitHub as well. And so these are some kind of famous open source project that's been hosted on GitHub itself. And so the Visual Studio Code, the editor we are using for this module itself, is an open source project. And this source code is actually also on GitHub. And there's other famous ones like the React, Angular, and the Vue we are covering in this module. These are again also open source projects, and their repository are also on GitHub. And there's other ones you might heard of, for example, like TensorFlow, which is a Google's library to do deep learning. Again, it's a open source project hosted on GitHub, and many others. Okay, as I mentioned before, and when you having a Git, you can collaborate with other people's, and each person have a local copy of the entire database, which allows you to do team development. But for this lecture, at least, we're going to focus on individual user cases, which is mostly how you're going to upload and commit your coursework files. But for example, you can definitely also use it when you're working in a group. You need to share code, and then GitHub repository will probably be a much better way than, say, emailed code between your team members or group members. Okay, and so before you can use it, and you need to create an account on GitHub. especially you haven't been there before. And then this is entirely free. Everybody should be able to create an account. So you just go to the GitHub page, sorry, GitHub. So the URL is just github.com. And okay, so when you first go there, you just look something like this because I already logged in. So it's different. So this is probably the page you would see. And then by the first option for you is just to create an account and to sign up for GitHubs. So all you need to do is type in some username and then your email address. You definitely do need an email address and then set up your own password. And then after that, you can sign up. And I think the GitHub will send you email to the email address you typed in here just to confirm that is you and you want to use it for your GitHub account. And that's all. So that'd be fairly straightforward. Not different from, for example, you sign up for a new email address, sign on Gmail or something similar. Okay. And so if you're following along, I would recommend you give it a try and then set up the account now. Shouldn't take very long at all. Okay. Okay. Can I see a show of hands? How many of you actually are trying to follow along? And if you are trying, please try the yes button. And if you are not, just click no. Okay. I can see quite a few people are trying to follow along. So I'll give you a little bit of time so you can actually create an account. Because if you can't do it, you can't really do the other steps later on. Okay, I'm gonna clear the current vote now. So now please click the yes when you finish creating your account. And then we're gonna go to the next, click next step. Okay, yeah, it wouldn't take very long. Okay, people are getting there. Give you 1 more minute. Just 1 more minute and we'll continue to next step.
It's cold outside the union.
Yes, it is, definitely. It's raining as well. Okay. Okay. I think that's probably should be enough time for you to create an account on GitHub. And then we're gonna go to the next step. So after fill these out, next step is actually to create a repository. And so this is where you save all your Git. As we said, we're gonna create a repository on GitHub first. And then we're gonna make a copy of that onto your local computer. Okay, and so let me just show you. So I'm gonna sign in as myself now. Okay, and so the interface you see when you first log in will be a bit different. And because I have lots of repositories, so it looks fairly busy here. And what you need to do is go here. There's this plus sign on the top right corner, and then choose new repository. and you would have some interface like this. So this will show your, and if you are logged in, and then you can type in your and repository name. Okay. For example, that's my repository name. You can call it something else. It doesn't matter. Then there's a few options you need to do. So here is description, and it's completely optional and doesn't really make a difference. But usually, just to explaining what the repository is for, demonstrating how to use Git. Let's say, and then you have this option here, and you can either make it a public or private. And so if you make it a public, that means everyone else can see the code in your repository, and they cannot make changes. They can see the code, but cannot make changes. And if you pick private, that means other people cannot see your repository. Okay, and then for now, it doesn't really matter. This is something you can also change later on. Okay, and let me see the other things. Okay, so in the slides, I said choose private. Okay, and you probably want to pick up this one. So this is add one file to your repository. So make it not empty and make it easy for you to clone it. So I would recommend, say, add a .readme file. And I would also try to use this add.gitignore file. And what it is, it will tell Git to ignore certain files, don't including them. Because, and for example, on Windows or Mac, the system will generate some default system files, for example, thumbnail or something, and you can ask Git to ignore those for you. And then you can choose. There's lots of predefined ones you can choose from. Oh, it doesn't have one for Mac. That's interesting. So most of these are just different languages, and it will automatically avoid certain. Oh, Python. Okay. Do they have Java? Okay, only Java, no JavaScript, HTML, no. Okay, maybe you will. Again, this is something you can manually create later on as well. And also you can choose a license. And license means you have different type of, say, open source licenses, and they have different implications. It would not matter too much here, and because it's unlikely other people will be using your code. And then you just say create repository. And now you have a new repository. So because I choose to including a README file, so you should see this one here, and this is automatically generated with the name of your repository, and that's the description you typed in early when you're creating the repository. Okay, I'll give you a little bit of time to see if you can follow on, just to create a repository now. So, and please click yes once you finish creating the repository. Okay, I've got a few. Okay, and hopefully you create your first one now. And the next step in terms for our part is actually to clone the repository locally. Okay, so the clone is like a special terms used in Git. essentially what means is to make a copy of the repository, and locally means make it on your own, copy it onto your own computer. And so this interface is a little bit older one and is updated recently, but what you need is to get the URL of your repository, and then you can do it on your computer. Well, make a clone or make a copy onto your computer. So now you need to go to code, and this is the clone option, and HTTPS will be fine, and this will be the URL for your repository. And what you need to do, just click this button, and it will copy that URL. And that's enough for now, for the first step. Okay. Okay, so next what you need to do is you need to open a command or prompt a terminal window, something similar to what we did before. For example, here, that's what we did before, to run the actual clone command. And to do that, first go to the directory where you want to have your repository. And so the repository itself will be saved just as a directory. The name of the directory will be the name of your repository. But for example, if you want to put that repository on your desktop, then in the command line, go to your desktop and say, in my case, I want to go to, okay, maybe OneDrive, my OneDrive, and then going to my teaching, and then, clear, okay,
Sorry, Kai.
yeah.
We just use the terminal which we have on the in the Visual Studio.
Yes, it's the same. So if you want to use the terminal
I
in your
think that
Visual
one
Studio
is
code,
we don't
that's
need to
also
look for
fine.
a file.
Sorry?
I like if we don't need to search for an exact path, like the folder, like have.
Yes, yeah, that's
It's gonna
fine.
open directly on. It's gonna focus
Yeah,
on the folder which we are working on.
yeah. Actually, what I can do alternatively is just, I mean, it's a little bit, take a little bit of time to find the right directory on the terminal. So in my case, what I'm gonna do is I'm gonna just right click. I say new terminal at that time. So I had a terminal there. And you can see this is where it is. Let's say this is where I want to have my new GitHub repository copied here, cloned here. And then the command you need to type in is say git clone, and then paste the URL you just copied from your repository, GitHub repository page. So this is, if you click this one on your GitHub page, and the URL should be copied. So what I will do now is I just type in git clone and then paste, and you can see that is my URL there. And then press enter, and if you see some message like this, that means it's working fine. So it says cloning into this one and counting number of objects, do some compression and transfer everything. And once download, it will unpack. I mean, you don't really need to know what the message means, but if you see something similar to this, that means it's working fine. And you can see now I have a directory called CST3145 demo, which is the same as my repository name there. And if I show, and it's inside has one file just called readme.md. So that's this file on my repository. Okay, so So that means now I have a copy of the repository on my computer now. And this is now linked to the repository on github.com. And then later on, I can upload my changes, or in the Git terms, it's called push my changes to the server. But for now, okay, can I see a show of hands? How many of you managed to clone your repository locally? Yeah, a few. You can either show of hands or click yes, up to you.
Yeah, Kai, I did the git clone and then I
Yeah.
pasted the HTML thing, but then
Yeah.
what do you do after that?
And you don't need to just press enter. So you type in command like this, right? So git clone, paste the URL, press enter, and it should show some message here, which is Git doing his work.
Then how did you access the file folder?
What do you mean access the file folder?
Row ls, and that doesn't work for me.
No, ls is on Mac. So on Windows, you want to type dir, which is list ir directory.
Yeah.
And it should list everything.
Oh, I see now.
Yeah.
Yeah, it shows CS345.
Yeah. So obviously, dir doesn't work on Mac. Okay. So now you have your repository cloned locally. Okay. Okay. And so this should have a directory called learn git. In our case, it's called CST3145 demo, and just depends on the name of the repository. And inside it should have readme.md. And then this is what we have here. If I list the files inside the directory, which is I did here, it shows, okay, there's a file there. And this is just slightly different display of the same information. It says you have the readme.md file with some other attributes, for example, when that was created, etc., etc. Okay, and so if you can see these, that should be fine. So just doing a quick recap. So we create an account on GitHub, and then we create a repository, and could it be some name? In this case, it's called CST3145 demo. And then we clone the repository onto our computer. So you have a directory with the same name on your computer now.
Sorry, Kai.
Yeah.
You can only clone it if you do the config part, right?
Yes. You can only use it after do the config. You have to do the configuration.
Yep. Okay.
Yeah. Also, there may be a slightly complication. Let me see if anything. Yeah. And also the two are now connected. So there might be a slightly complication before as well. And so if you choose the private repository when you created it, and then when you try to access GitHub repository, and the Git will ask you about your GitHub username and password for the first time. So that'll be a bit different than the Git configure you did before, which you set up your name and the email, and it will ask you for your GitHub username and password, which is what you entered when you created the GitHub account. Because the repository itself is private, not everyone can see it. So you will need to enter that information the first time. And then afterwards, Git will remember your GitHub username and password and will not ask you again. Okay. Okay. And now we're going to switch to Visual Studio Code. So it has built-in support and for using Git. And so you can do everything in the command line, but I find it's a bit easier to using the built-in features in Visual Studio Code to do things related to Git. And so first thing we're going to do is we're just going to open the folder which you just cloned from the GitHub repository in Visual Studio Code. Okay, and then later on, we're going to do most of our work in the terminal window, someone already mentioned, inside the Visual Studio Code. So you don't have to use something like this to do. Okay, and then the other benefit is saying the terminal tab in the Visual Studio Code is always showing you the folder where the GitHub repository is, unless you change it manually. Okay, so let me see. Okay. So first what I'm going to do now is I'm going to open the folders I just created or just cloned in Visual Studio Code. So for me, what I can do, where's my window? No, I didn't have any. Okay, on my computer, I can open something like this. And on Windows will be slightly different. And you might have to, okay, let me just do mine first and then I can show you what you might be able to do.
Hello.
I'll choose the ones I just created. This demo, and this is my demo file. I'm gonna open this in Visual Studio Code. So it will be in Visual Studio Code. And make it slightly bigger. Okay, and so you can see now I opened the folder on my computer, which is the folder which I cloned from the GitHub repository. And most Git related things is in this one here. And the third icon on the vertical menu bar, and by default, if the menu bar is on the left, you can also put it on the right if you want. But for now, you can see, okay, you just saw one file, and which is called README. And you can turn on the terminals, I think is this file here. You can click one of these buttons. I think this one, says 0 error and 0 warning, and then click the terminal, and this will show you the terminal. If I show the files, you can see it has readme.md. Okay, and then if you open the folder, I mean, on your computer, and you might have to go to say File and Open Folder, probably on Windows, and then select the folders where you clone the GitHub repository. And if it is a GitHub, if the folder is a GitHub repository, and then Visual Studio Code will automatically recognize it and start to tracking the changes and providing all the options for different Git commands. Okay, and so first, for example, I open up the only files we have and I add a little bit more information. So let's say this is my first changes. Okay, so you can see what I saved the file now, and you can see what happened here. So you can see this GitHub icon now have one next, or to add one to it. That means it detects one changes. And if you click, and you would see something like this, and you can see listed under the changes, it says readme.md. So this is like the first state we mentioned earlier on. So the Git detect there's changes in your file. So in this case, it's called readme.md. There's changes in this file. Okay, and then There's many other functions, which is almost all the common ones you need for Git will be provided in this Git panel. So we're going to use that for our module mostly. Okay, and so far we have a copy of the repository on our computer. So that's what will be the working directory. And now we made some changes to one of the files. Okay. So it was talking about different files. Obviously, currently we have almost empty repository or directory. Only has one files, and that's the files in the state of being tracked because it was in the repository before. And you can add a new file. For example, now I'll switch back to the first one. I can create a new file. Let's just call it index.html because I'm going to do all the work. And then currently, that file is not tracked. It's not tracked because it can detect there's a changes. There's a new file created called index.html, but so far that's not in the GitHub repository yet. So that's an untracked file. So these are called untracked files. Okay. Yeah. Okay. Now we're going to start into making some of the changes. And GitHub or Visual Studio Code will detect any changes you made in the repository folder. And so as we already shown, this can be just make changes to existing file or creating a new file. And actually, for this one here, for the index.html, you can see a little green U on this side. So that means this is untracked file. That's a new file, which is not in the repository yet. And where this kind of brown colored M means there's a modification or changes to this readme file, which is what we did. Okay, and so in this particular case, you can see there are 3 changes. It detected. So it says there's some changes to the index.html file. There's a new file called newfile1.html, and there's another file, new file called style.css. Yeah, and it's slightly different. In our case, we have a new file, untracked, called index.html, and some changes to the readme.md. Okay, and the next one is to stage your changes. So basically, you are telling Git, say, these are the changes I want to include in my next version. Okay, and you don't have to include all the changes in one commit. Say, for example, currently I have these 2 changes, but I don't have to include in both in my next version. For example, I only want to include the change to my README, and that's completely fine. And all you need to do to stage a change is just by clicking the plus icon next to a file. Okay, here I'm gonna just click this icon here. If you mouse over, you will see the icon. Okay, and you can see it was display says, and stage the changes. You have readme.md, and there's another unstage the changes. And only this part will be included in the next version. And in these examples, you can see in the screenshot, it says you have staged the changes, including these 2 files. But this one is not included in this particular change. So what is a good thing is you want to make all the changes and related to the particular, for example, you had a new feature in your code. Now you can display, now you added the add to cart button to your app. Then you may want to put all the files or all the changes related to that function into one commit and put all those into one staged changes. Okay, and the next part is to commit the change. That means save the changes to your version database, create a new version. Yeah, and so you need to do this. And once you commit it, and it becomes a new version, and you can come back later on. And that also means a change you can upload to the GitHub server, making it very difficult to lose afterwards. Even you lose a computer, it will be still there. What you do need to do is you need to type a message describing the changes are. So basically, you need to tell people, sometimes yourself, your future self, and what this commit or what are the changes in this commit are for. And so you just type your message here. Say, I can do something, say updated, let's just say added a new line to the readme.md file. Okay, and what you do to commit is just click this button, the tick icon here, and you click, and you can see now that change disappeared. You only have this one now, so that one change is saved to your new version now. Okay. So what you have done so far, or what we have done so far, is I created a new version. That version includes a change to the README file, and that change is currently saved or committed. But that change only exists on my local computer. It does not exist on the GitHub yet. So if we want to back up the change, or which we should do all the time, is then to upload the change to the server, and this is called push in Git. And so currently the change is only in your local version, but it's not on the GitHub yet. And so if we go here, you can see this is my GitHub page. I can refresh. You can see it says one commit. So that's the one that's the commit when we first created the repository. You can click this one commit, and you can see here it says initial commit 24 minutes ago. That's when I created the repository. So it certainly doesn't have the commit we have done locally yet. If you remember, in the Visual Studio Code, we made a commit, where we changed the README file. And you can also see here, you can see the README file is still has title and description, don't have the line of text added later. So now what I can do is I'm gonna actually push the changes. So the changes will be added to the GitHub repository as well, not just locally. And so you can find the push command in the straight dots. So if you just click straight dots and then click push, and the Visual Studio Code will do the rest for you. And as you can see in GitHub, so just go here and then click push. And you see this little thing there, that means it's doing something. But also if you open up and one of the terminal option is output, I think. Okay, not here. Okay, anyway, so now, I mean, there's nothing much to show here, but if you go back to your GitHub page and you refresh your page again, and what you can see is now it says 2 commits now. And if you click that one, just waiting, you can see, okay, I have a new commit now, the second one. So that's my message I typed in. So add a new line to the readme.md file. And if you go back to the actual main page of your repository, and you can see now in the actual README file, you can see this line is now added to the README file. So basically, so these are now your different versions. You can always go back to any of these versions later on, but that's the second version we created, let's say. And just very quickly, there's lots of other Git commands that you can get from this three-dot menus, and you can do pull, do clone, do checkout, and many other things. So you don't have to type them, you can just use it, select them from the Git menu in the Visual Studio Code. Okay. And so this is so for the group work, you need 5 commits. So we just did 1. And you can see now you have 2 commits here. Okay, let's just say we have 2 commits now. And I could add another one quite easily. For example, I can now stage this change by clicking the plus sign. So now that becomes the stage the change. I can type a message, say I added index.html file, but so far and it's still empty. And I click the commit button. So that becomes my second commit. And I can do the same by pushing this to the server. So I can see the changes on github.com website as well. So I click push. There should be a little line moving on. Means it's doing the job. And now if I come here and I refresh again, okay, you can see now that's a third commit. It says added empty index.html file. If I go to the kind of main page or starting page of the repository, what you can see now is there's actually 2 files in your repository, the readme.md and this empty index.html file, which you can actually click and it'll show and the file content currently is empty. Okay, and so for the coursework and group work, you need to do 5 of these commits. And so basically, once you finish certain properties or features in your code, you should make a commit. And don't wait till the very end before you're making any commits. And then for the individual ones, you need to do 10 of these. Okay, and we already done this a few times. If you click on the 5 commits, or here the 3 commits button, and it will actually show you the list of commits, which we already see. It tells you who made the commit, what is the message, when that was made, etc., etc. Okay, and the other thing, which is the opposite of push, is called a pull. And what it means is, we already mentioned early on that you can have multiple people working on or contributing to the same repository. And then once one person makes some new commits or changes to the repository and push them to the server, for example here, and these changes does not exist on the second person's computer yet. Say, for example, we have 2 people in the team, and the second person made a copy or clone of the repository when there's only 1 commit. So when I add these 2 new commits, the second person will not have them yet. And this is when the second person to get the latest version, you need to use pull. Yeah, so you get the latest version from the GitHub if there's anything new there. Okay. And also what you can do use pull is you can also use that to get the new repository from the code. Yeah. So to do pull is quite easy, and you again just select straight dots and you click the pull. And and this is only mostly useful when you have say a group of people and you probably want to do pull quite regularly. So it's just straight dots and click the first one option is pull. And I can do it as well here, and it will see go check the server. But because I already have the latest version, then there will be no change here. But say if you have a version which doesn't have index yet, and you do a pull, it will download the latest change to your local copy. Okay, and so some comments about doing commit. I'd already mentioned, try to commit often. Don't make a lot of changes until, for example, until the entire coursework is finished before you make a commit. So whenever you create a new page or complete a new feature or function, make a commit and add a descriptive message to describe what the changes are. Okay, and then Git will allow you to go back to any previous commit or previous versions. So you can, for example, here, currently my code is in version 3, but if I want, I can always go back to version 2 or version 1, which is completely empty. So this way, if you have multiple commits, you can always go back to one of the previous states you want, but you only have one commit, then you have to either undo all the changes or have no changes, or undo none of the changes, which is give you much less options. Okay, and also why this is useful is it could happen, say I made some changes which break my code and I can't get back to what it was before. And if you commit often, you should have a recent version or commit of the changes which contains working code. So that's why it's important to say whenever you completed a page or made a feature working or function working, make a commit. Then you have a version that you know that's working. And then later on, you can always go back to that if necessary. Okay, and for the coursework one, that's why I encourage you to make 10 commits, and you actually may have more than 10 if you actually follow this guideline in terms of making a commit every time you make some progress. Okay, and then let's do the last part, which is about the GitHub pages. And so that will makes your page or up live online so that people can see, like you're hosting the page on a server. Okay, and so this is part of the GitHub repository features. And so there's nothing special you need to do. All you need to do really is change the settings. Okay, and before I do that, I'm gonna say go to my GitHub repository or in the Visual Studio Code and actually add some content into my index page because currently it's empty. And when I made it live, it will not see anything. I can add something to my HTML page. And yeah, just say I have a H1, which says this is a Git demo for CST3145. Okay, and so, and you can see here now, and Git again detect the change. You can go there, there's the changes, you stage it, and add the message. I call it add content. Okay, let's say add heading to the index.html file. Okay, and then I click this one, which committed the change. So that becomes a new version, save the locally. And then I'll go here and go do a push. And that uploads my changes to the GitHub server. Yeah, and then I go here. And if I refresh, okay, I can see the false version I created. And if I actually looking at the file, if I click on index.html file, you can see the code I wrote is now there. Okay, and so the next part is actually to make it online, visible online using GitHub pages. And so the first things you need to do is go to the settings. So I go to my GitHub page. I go to my settings. So this is a setting page. Oh, why it's empty? Okay, and then scroll down to the GitHub pages section. So you go to the options. So that's the settings. You scroll down, and there will be a section called GitHub pages. Yeah, so this is what you need to change. And so if you set your repository as private, and you'll see something like this. It says update or make this repository public to enable the pages. So basically, if you have a private repository, you cannot use GitHub pages unless you upgrade to a paid account. Obviously, we're not gonna do it today. So instead, we're gonna just change this to change the repository to public. So you can do this in the so-called danger zone, and you can say the change repository visibility to public. Okay, let's do this. So I go here, I go to my danger zone. This is what you need to do. It says the repository is currently private, and I change the visibility to make public. And tells you what this means. And to do this, you have to type in this one to confirm. So I'm gonna just copy paste. And I say, I understand, and change the repository visibility. Okay, now if you scroll back down again, you can see now it says the repository is currently public. And also this part also changed. The GitHub page, it's not like that anymore. So it should look like this now. Okay. And then to make it actual live, you need to pick a branch. We're not going to cover the details, but you need to change here. Oh, it's called the main branch now. So that just basically means which code you want to show or display on the GitHub pages when it's used. And you click save. You should only have one. Again, let's scroll down. It should look like that. The branch is main, that's what will be the root. Previously it's called the master, which is, okay. Then the next thing used for is it will have this now. That's the public URL to your GitHub pages. Okay, so anyone has a URL can see your online page now. In this case, it will show the HTML index.html page I put in. So if I open this in a new tab, and it will see this. So this is the headings I put in my HTML file. So let's be working there now. And also I can, just to make sure it's actual public, and I will log out myself. So I'm not signing in anymore. And I can go here. I can just refresh the page again. You can see it still displays. So it doesn't matter. It doesn't have to meet me. Anybody has this URL will be able to see your page or your app, the Vue app you created. And that's kind of hosted online, just as you host a web page on the server. Okay, and the important things is just to remember this will be the URL. So actually the URL will be the actual URL will be, and this will be your GitHub username, and then it's always followed by github.io, and then this will be your repository name. So in this case will be CST3145 demo or something similar. Yeah, which is the repository here. Okay, that's it. That's all we want to cover today. So we covered what is version control, what is Git, how to use GitHub, and then finally how to use GitHub Pages. And in terms of reading, that should be the chapter 1 and 2 of the Pro Git book. So that should be on the reading list. It's a free book online. If you go, oh, this is the wrong module. If we go to the module, and go to the list, reading list. And yours might look slightly different, but that should be the book. And it's a free one, and it covers lots more. And what we covered today is just chapter 1 and 2. So it's introduction and the very basic, but the common ones we need for the Git. Okay, that's everything for today now. Let me stop the recording. Stop.